In this video, I'll show you how to model direct variation equations. This is part 2 in the series. Question 1 asks, the force F needed to stretch a string is directly proportional to the distance x. If it takes 15 newtons to stretch a certain spring, 28 centimeters, how much force F2 is needed to stretch it 34 centimeters? The way we model this equation is by using y is equal to kx, but instead of using y, we'll use F for force. So F is equal to k, the constant, and x will represent our distance. We are told that if it takes 15 newtons to stretch a certain spring, 28 centimeters, so that's our first point, 28 centimeters, the distance, and 15 newtons. How much force is needed to stretch 34? Substituting these values into F and x, we end up with 15 is equal to k times 28. Our k is equal to 15 over 28. This fraction can't be reduced. Now I can rewrite my equation with k filled in. We have F is equal to 15 over 28 x, and we're looking for F2. They want us to find that out when it's 34 centimeters. So substituting x is equal to 34, we have 15 over 28 times 34. Let's use our calculator. 15 over 28 multiplied by 34 gives us 18.21. 18.2 newtons. That's the answer for question 1. In question 2, we're asked, the resistance R of a conductor is directly proportional to its length L. So we have R is equal to KL. If the resistance of 2.60 kilometers of a certain transmission line is 155 ohms, so this time the length is 2.60 and the resistance is 155 ohms, find the resistance R2 of 75.0 kilometers of that line. This will serve as our independent variable, our x if you will, and this will serve as our dependent variable. Let's start off by finding out k. 155 is equal to k 2.60. Therefore k is equal to 155 over 2.6, which is 59.6, or approximately that, 59.6. Rewriting our equation, R is equal to 59.6 L. Our L is equal to 75. R is equal to 59.6 times 75. Let's find out the resistance. We end up with 4,470. 4,470 ohms. And there you have it. 2 examples on how to model direct variation equations.